Okay, so what is it? Today is September 11th, and we are chatting about constrained impersonation. I think you guys can see my screen. Text big enough, or y'all want it bigger?
Maybe one notch bigger.
All right, one notch as requested.
Great.
Okay, so how did I get here? Um, so think through the KEP, there was a handful of little open items around the performance, the exact semantics of like how when you granted these permissions, like exactly what the union of them was. And in general, I think for a while I've been unhappy with the structure of how impersonation works, um, just in the way like you read it. Um, so I basically rewrote the whole handler uh, from scratch. So the way it's wired in, and yes, I know nobody can read this. Uh, it is very much like if you have concerned impersonation on, you get this one. If not, you get the old one. Uh, and the reason there is basically I didn't reuse any of this as code other than like how it extracts like user extras from the headers. Um, so I guess unless anyone has any immediate questions, I'll just walk you through how it works. I don't actually know if Jordan, David, if you all have had time to read it. Um,
So the question that I had, the top level question I had is, does this change the semantics of how an external client perceives constrained impersonation to work, or does this just change how we evaluate it to do things like use the cache that you added to like optimize which check we make?
okay. Um, so the answer to both is yes. Uh, specifically around unioning of different permissions and how that works out. So if you want to do that first, what I did to sort of demonstrate the difference is I took the existing PR for constrained impersonation that tried to edit the existing stuff, and that had integration tests associated with it, right? And so I have the diff of those integration tests, so they still pass. I just had to edit them to make them pass to under the new constraints. So I can walk you through that diff first if you prefer doing that instead of looking at the code first.
I am most interested in the change in semantics. The change in spelling, yeah, you're a grown up. Well, you're almost a grown up. Uh, but but
You don't have enough white hairs? Okay.
Yes.
the change in semantics, I would like to understand, especially if we lose power.
D- David, you said change the semantics of constrained impersonation. Did you mean change the semantics of impersonation?
No, because I'm assuming that Mo knows he can never change the
Okay.
semantics of
All right.
impersonation. Constrained
So
impersonation
change
is
the semantics
often
of constrained impersonation as was discussed in the design to.
Right.
Okay.
Yeah.
correct. I
So
want
Okay.
to know what the delta is there. Um,
I have taken great care to meticulously recreate the
Yeah.
exact semantics of original impersonation. So if there is a delta, that is a bug and it will be fixed. Uh, the semantics that are different between what's exactly in the KEP versus what's implemented here. One is when the scheduled node logic runs, it is stricter in that not only does it need the node name to be there, it also expects a pod name to be present. That's one. Previously, that was not being asked for. So if you were trying to impersonate a scheduled node, your user and the node you're on was enough, but you didn't need a pod reference. So you didn't need to be anchored in both dimensions. To me, it didn't really count as being scheduled on a node if there wasn't a pod. Um, you all disagree, I could always certainly remove that if statement. It's obviously trivial to do.
I'm
Um,
trying. I So the verification then that you do is someone says in their impersonation request, like, "Hey, I am this pod," and you verify. that pod is still there. Is that like notably better? It doesn't bother me.
We,
So not exactly what you just said, David. It's that you come in as this particular service account, wanting to impersonate a particular node, and when that happens, the assumption is you've gotten through the authentication layer, so all the checks for references have passed as best as we care to check them through the service account token authenticator, right? So I don't make any reassumptions about that authentication layer. All I'm saying is, okay, you are service account A running on node B, and you are trying to impersonate node B. During that whole logic, are you actually running on a pod?
I so we can get tokens that are bound only to a node.
Mhm.
We can get service account tokens bound only to a node.
Mhm.
And the scenarios where I was seeing those used are things running on nodes, but not in pods.
Yeah.
And making it so that you couldn't use those credentials to do constrained impersonation seems bad. I'm not sure why. Like if you have if you have a a systemd process running host level on a node, and you
Mhm.
have come up with a mechanism to give that thing credentials scoped to the node,
Mhm.
why would we not want that thing to be able to make use of constrained impersonation?
To me, it came down to like, what do you mean by scheduled and the semantics thereof, right? Like to me, scheduling means there's a pod.
Oh,
If
oh,
scheduling is just node reference,
yeah, I missed the scheduling part. I like scoped to, constrained to a particular node was much more how I was expecting us to use that. So I like whether it's running in a pod or outside a pod, I don't actually care about that. I care about this credential is constrained to a particular node.
yeah. I mean, so I mean, we called the mode scheduled node, right? So it's like it's okay if we just change this to some other string that lines up, and
Yeah.
it's obviously trivial for me to delete like this one line and that.
Associated node, like associated node matches how I was thinking of this. I missed that we called it scheduled. Um,
Yeah.
if it's if no one objects, I would rather call it associated node and drop the requirement for there to be a pod name.
I'm convinced.
Okay.
Okay.
Yeah,
That's
that
fine.
sounds good.
Yeah. I am happy with that. It was undefined in the KEP, and I defined it one way,
Yeah.
and I am happy to change it.
Cool.
All right. So, do
Did someone start a? Oh, good. We're recording. We can take notes or yeah, however we wanna.
I'm literally gonna leave myself.
Okay.
Uh, but
Did
yes.
you just use AI to do a spell check correction?
No, that's just me right clicking and saying, please go land.
Oh. Sorry. I was gonna give you a hard time
Also, let me turn to make sure. Yeah, I'm gonna
breaking the environment for spell check.
yeah, I have to constantly disable the autocomplete from AI because it's dumb
Yeah.
and
All right.
drives me crazy. I'll stop complaining now. Okay, so that was one thing. I'm gonna come back to this diff because it's like one of the least important bits. Okay, so next diff is in the KEP, we said that when you want to do the impersonate on bit, that it would just be tacked on to the verb of the original attributes, and that's how you do the check. Now it's like scoped to the specific subset of the type, like of the mode of impersonation, right? So when you are impersonating a user info, that also needs to be included. So the intersection of these permissions is a little more tightly scoped.
Okay. So
Remind
this is
remind me what the
effectively we end up
possibilities
with
are.
three prefixes. Sorry. We end up with three prefixes, Mo. There's going to be one for impersonate on user info. There's going to be one for impersonate on associated node. There's going to be one for impersonate on node
And service account.
and service account. Okay.
Yeah. So it's a little tighter. It's
Yes. And the power is equivalent, so doesn't that doesn't bother me.
yeah. So when you grant these permissions together, you're at least scoping it within the modes that exist. Yes, within those modes, you can have overlapping stuff happening, I think that's probably okay. Trying to make it more specific, I think, just makes the verbs untenably onerous to even write.
And the the impersonator always knows the mode they are requesting.
The client,
Hmm.
the client, I would say, never knows the mode they're impersonating. The server tries the ones until
It
it,
tries to match them up. Okay.
yeah, and it goes from basically most secure to least secure.
Associated node to user info, I guess.
To service account, to user info, to legacy.
Well, if it's impersonating a node, it wouldn't be impersonating a service account. But yeah. Okay.
Yeah, that check will just say
Yep. Yep.
thing doesn't make any sense. Skip. Don't even try.
Okay.
Yeah. So that's how that's structured. So okay there. Okay. I'll keep going. Yell at me if I'm going too far. Then in the logic for matching, when you can be in a particular mode, um, for constrained impersonation, basically all of the modes that exist today only let you say the user that you want to impersonate. They do not let you specify groups at all, and they fill them out themselves. So, like when you impersonate a node, if you try to impersonate groups, you will literally not be allowed to hit that logic, and you will end up falling through to legacy impersonation. Um, but obviously, when the impersonation is complete, you do get the nodes group, you get the authenticated group, etc. Like, so your final user info is well formed. It's just that the way you make the request is just ask for the user. You don't make any other constraints. Same is true for the constrained impersonation for service accounts. Like you only ask for the username, don't ask for the groups. We will always set them to the fixed mapping that service account groups have.
So if you request groups, you don't match the constrained mode.
At all.
Is that what happens today with service account impersonation? Like we fill out service account groups.
Only if you did not impersonate them manually. And then if you try to impersonate them manually, we will do checks. And so all that behavior is still retained. It's just you fall
Yeah.
through the legacy impersonation. I'm just like, I'm not even going to try to figure out what you meant in the context of constrained impersonation.
What do we do with UID?
For
So
which
service accounts and nodes. When you authenticate using a service account token or you authenticate using a node certificate,
there is no auto population of that field, so it is empty.
what happens when you authenticate for real with a real service account token or a real node certificate? Do we fill out UID? I bet we do.
Yeah, yeah. So you can detect from the outside that a service account or a node is being impersonated by looking for the fact that the UID is not present. You can do that today, regardless of any of these. If you do that, I'm going to say you're being terrible and don't do that.
Okay.
So
So
when
a client that wants to impersonate in a way that will be acceptable to constrained impersonation would have to just ask for the username.
Mhm.
And if they wrote their client that way for nodes, today they would say, like, I want to impersonate the node name that I'm on, the username for the node that I'm on. And they ran that against an old cluster, it would treat that as just a username impersonation. It would do the auth-z check for unconstrained impersonation. And if it passed, they would get a sort of node user, but without the node groups that are going to be useful.
Great.
If you show up as a node username without node groups, node restriction admission doesn't protect against you, but node authorization also doesn't grant you any permissions, right? Okay.
Yeah.
Okay.
When Margot implemented impersonation for UIDs with the legacy stuff, David, you had reviewed that, and I think we had come to the consensus that we shouldn't try to like fetch a UID from the API and try to put it there. We can revisit that decision with constrained impersonation if we think it would be valuable. It's just that you get whatever UID the API server currently thinks is the UID.
Yeah.
I don't know. It could go either way. I don't like the fact that a client, like an authorization webhook or a validating admission policy, can see that and then decide to use that as the thing because, well, I'm saying it on a recorded call right now, so somehow that information is being projected to AI somewhere.
We don't even have the UID, like the user info when you come in with a certificate, derives the UID from the certificate and derives a credential ID from the particular certificate. So we don't even have the same thing to construct the equivalent if you were impersonating a node.
Yeah, I guess it's not the UID of the node object, it's the UID of whatever random credential you have, which we recently did make certs be able to do with a custom
I
ASM.
don't think we populate that in node certificates, but
Right.
My
Yeah.
default would probably be to leave it empty.
yeah.
Yeah.
In terms of you don't get to specify the groups. I'm okay with that. It does make it a truer impersonation for those particular types.
Makes it truer and it makes it cheaper to check. Like it's one less thing to worry about. Like what if they requested groups, but they weren't the groups that they would have gotten.
Right.
And if we ever in the future decide like, oh, service accounts should definitely have this other group or nodes should have this other group, we would add it to the real authenticators and the real tokens and the real certificates and to the impersonated ones at that point. So I don't think we will probably, but I like filling it out and only having them do the username.
Okay. All right, so that's good. Here's another example of the whole, when you're scoping to a mode. So instead of impersonate on, it's now impersonate on regular node. Just as an example, let's see what else changed.
Is just do we think people will make mistakes? Impersonate on node, it's not immediately obvious that lets them impersonate any node. Do we want to be explicit and say like associated node or any node or all like
Impersonate any node seems fine, or impersonate on any node.
yeah. I
Okay.
like there's no difference in power. It's more just like will people understand what they're granting on? Like impersonate on node feels like, oh great, I'm like scoping them to a node. It's like you're not actually, you're letting them do any node.
So like that.
Something like that, something that's clearer. That it also starts with A, which matches associated and makes me happy for no reason.
Okay. That's fine. So yeah, so I can rename that to any node. I mean, yes, you can technically constrain it to a specific node by setting the name in your cluster role. It's just impractical because node names are like generally ephemeral.
Yeah, I think that any node is more accurate.
It's just it's not something reasonable to
Do we need the power to restrict to a particular node?
um it is basically just how the rest of all these checks are structured.
I guess one advantage of that is if you made a webhook and had special nodes, you would be able to say no, not this one.
Yeah, you could. If you somehow have the ability for your authorization or admission system to look up extra information and then make decisions based
Yeah,
on.
I could see it being useful for that, for external deny checks.
So any node, the SAR check is still going to send the name of the node.
Yeah, because that's I mean we can go all the way down to like where the actual subject checks happen. Good grief, this file's gotten too long. All right, so no, I think I went too far. That's what I get for not like.
A SAR check for any node, when all the checks will do, will also include a node name. It's a little weird. Like in the permission granting, it's fine. When we're checking the permission, that reads weirdly, but maybe it's fine.
Yeah, so in here, when we do all the node stuff. Yeah, the name is
Do
set to.
you also, though, Jordan, see a reason to allow for the classification of different kinds of nodes? Like, I want to let you impersonate these kinds, and our authorizer doesn't do it. But
Yeah, it doesn't bother me sending the node name so that an out of tree authorizer could make that determination. I'm just trying to figure out if any node is like a weird. Do we?
I mean, so the resource is still nodes. The verb is impersonate whatever any node.
Like
could
so
be
RBAC
impersonate
would
this
like
node.
in person. I don't know. Arbitrary node.
You're just stuck on A's.
I'm
So
really not.
arbitrary node would be fine. I think, like, looking at the practical usage, I could see that reading better in an RBAC policy.
Like it lets you impersonate an arbitrary node. We don't enforce any association requirement, and like like impersonate arbitrary node foo in the SAR subject access review reads better than impersonate any node foo.
I
Yeah,
can't
agree.
Okay, let's do that. And we still have A. Amazing.
All right, arbitrary node it is.
Great.
Excellent. I like it. All right, continuing on. Let's see. So we decided we're going to get rid of that diff, so that'll go away. We already talked about how this part is good and we're happy. Okay, so then the other thing that came up is pretty minor. It's basically what error do we want to return to the user? I don't like what I have right now, which is it tries to return all the errors that it encountered, which I think is just absurdly bad looking.
Yeah.
If we're okay, my thought process was that you would just get the first error, which would almost certainly be for the first constrained impersonation mode that could have reasonably matched your request.
I like the error message guiding people to grant the most scoped permission possible. So if you show up and you asked for a node username and your user extra has, like, you have a node claim in your user extra, then giving them error messages that say, if you have a node claim and it matched the node you asked for, then giving them an error that says you don't have associated node for permission, like that would be great. If you grant that, this would have worked. If you have a node claim and it didn't match, then giving them an error message that says you don't have arbitrary node permission. And if they grant that, it would work. That's great. Like, so giving them an error message that has breadcrumbs to like the most scoped permission they could have granted that would have let the thing work, I like. Because what will happen is people will do a thing, they'll get an error message, and then they'll go write an RBAC rule that grants whatever the error message was complaining they didn't have.
Or if we don't give it star.
Well, we can't help those people.
Yeah.
Those people don't care about this at all. They just grant cluster admin.
They already granted star. They'll never see the error message.
Exactly. Everything will always pass.
So does that, like, the error message, including the most constrained thing they could have granted that would have let it work?
That is potentially more than one error.
So you'll only get the first one of those, and then when you run it again, then you'll get the next error, but at least it'll match.
Okay. I'm okay with that.
For a given request, what do you mean for
So for example, right, say you have no permissions to impersonate anything. The first constrained impersonation check will run. It will fail because you don't have like the impersonate on bit or whatever, whichever, I can't remember which one we do first. Yeah. And then you grant that one permission, you run it again, then you'll get the, oh, you don't have the ability to actually impersonate the username you're trying to impersonate. Like,
okay, well, yeah, that multiple errors is fine. I just don't want to return an error that people will react to by jumping to like the least constrained thing they could.
Right. Yeah. So that's why I was like, I don't want to return the legacy error because that just basically tells you not to do the right thing.
Yeah. And I don't think we need to aggregate all the things. So a single error message includes like 5 things they would have to grant, or 3 things, however many the user and verb and the whatever.
I think it's slightly nicer if we do, but I also understand why it would be unnecessarily expensive to do so for rejections. So first one's okay.
All right.
Ben had a comment in the chat.
I can't see the chat. Somebody tell me what he said. Ben, tell me what you said.
I just said arbitrary implies randomness, right? It's like kind of whimsical or just kind of non-specific. So just not to bike shed on that term further, but I wonder if like a word implying specific would be better than arbitrary, or which kind of implies random.
The thing I want to make clear is that there's no requirement that the node be associated with the impersonation.
Associated.
Well, I mean, it might be, but it's not required to be.
Oh, that's true.
So I'm not attached to arbitrary.
I'm just gonna use question marks.
Yeah, just making it clear that this could be any, like, it could be any node. So if you grant a role that doesn't constrain it with resource names, then it is arbitrary nodes. Like this does let you impersonate arbitrary nodes. If you constrain it with resource names, then it is arbitrary node named whatever you constrain.
But more of that.
So I think arbitrary actually kind of works. I don't know. I'm not super attached to it, but I just want to be clear. There's no requirement that it be associated. So.
Okay. Let's see, what time is it? Okay, we're halfway through.
Sounds good.
So I think we've covered now. I think the diffs. Let me open up my to-dos real quick so make sure that there wasn't stuff associated with the diff. And I realize you guys can't read the tiny text. Okay, so we said that. In the KEP, it was not super clear where this new auditing information for constraint is supposed to go. So we said in the KEP that we would make it so that you could see in the audit logs like how, like which mode basically you ended up in when everything was said and done. There's 3 possible choices: an audit annotation, a new field inside of the impersonated user structure, or a sibling field to impersonate user. Don't care. Please tell me which way you guys prefer, and I will make it do that.
My instinct is a new field under impersonated user, but I can't remember exactly what that struct is.
It's using the standard authentication v1 user info one. So I would make a new struct, embed the other one in there directly, and then add the field beside it.
I guess the impersonated user is the user you ended up with. That is not exactly the same thing as what mode you got used to get there. I don't know. David, do you have an opinion?
I don't remember the struct well enough to comment.
User and impersonated user are identical today in the audit event.
I'll show you. So
because they're both user info structs.
Gotcha.
Yeah. So this thing.
Yeah.
Well, that's obviously not going to work then.
I mean, we can change it, but it is like the mode you used to get the impersonated user is not the same thing as.
I agree.
Okay.
So an impersonated mode right beside this.
Did we ever add anything around like authentication authorization? We never added fields for that info. We've talked about it like 100 times.
Right. I can make a new struct for authentication bits and start shoving it in there. If you prefer. I don't think we should use an audit annotation. I feel like that impersonation is a first class thing. We should not downgrade it to random untypedness.
I agree. Either a peer field or starting a struct for to have like authentication stuff in it. Knowing that there's other authentication layer related things we want to start adding, like which authenticator was involved in this, like
Yeah, so something like authentication metadata.
something, or yeah, a thing to hold information about how you authenticated, and one thing in here would be impersonation constraint. Sure.
Okay. Are we do we care enough for any of this stuff for this to be a pointer, or can I just leave it as a string? And if there is no impersonated user, you know that this is just going to be the empty string.
I don't want to. I don't want to serialize it if you weren't impersonated and you weren't. So
Okay.
whatever we need to do to like not pollute output with empty junk.
Are you happy with omit 0? Can we
Omit zero doesn't work nicely with structs,
It
unfortunately.
does. Omit 0 works perfectly with structs.
Did they
I this has proto decorations on it, but I don't think we actually support proto serialization. Proto does not support omit 0. The main thing I care about is we don't pollute whatever gets serialized if it's empty.
just don't?
So I'm omit 0 is fine with me if it's
Okay, so just I can write a test that guarantees that. So what would that I think what you're saying is when a regular request that gets audited today that doesn't use impersonation goes through, because this will only have the one field, you're saying just that should have no diff at all.
I, until we have data that's useful to put there, I would prefer we not.
Yeah, that's fair. I'm okay. I will make that happen. Right.
And in the future, if we add like which authenticator authenticated this thing under there, which we probably will end up doing, then every request would start having data there, and that's fine. Like once it's useful, yeah, include it. But until then, don't.
So the impersonation constraint string there would be like the associated node or arbitrary.
It'll be arbitrary node, associated node, service account,
User info.
oh, and legacy when you use.
All right, yeah.
That's what I called. That's what I stuck in this value for legacy impersonation is the string legacy. I can also.
Oh, so there's a distinction between constrained impersonation of arbitrary users, which is like the user info, and unconstrained impersonation. Interesting.
Yeah, so
Maybe,
I called it legacy. I can leave it empty string if you guys just don't want it to show up at all, and you just infer by the lack of its presence.
or just call it
If you have an impersonated user and there's no impersonation constraint, then I think that shows you used impersonation and you weren't constrained.
Okay. So then I should make this line the empty string.
or unconstrained to be the negation of whatever we make now. But
Yeah,
then it's
we
like
can.
if we add the constraint mode in the future.
Right. Yeah, I'm fine just saying this is the empty string because there's
That preserves the current shape of audit events for impersonated requests.
Yes.
Okay. And so then I guess I just need to make sure. I gotta fix this I gotta fix it so it doesn't include the verb. That's fine. I can do that. No big deal there. All right. So then let me check through all my things. Okay. So I think now I just need to walk y'all through the code so I can ask you some of the questions I had regarding the actual implementation. Okay. So first bit of difference is when we process the impersonation headers, um, instead of converting it into some other structure, we convert it into basically a user info that is being asked to be impersonated, which for all the, as we discussed, for all the constrained impersonation modes, other than the user info one, basically just involves setting the username. Um, so at this point, what you have is like a very high level intent to impersonate without any sort of completion of what that means yet. And obviously, if it's nil, there's nothing to do. Um, then we basically get the authorization attributes that would have been associated with this whole request, which is basically, request info plus the user that is doing the request. So at this point now you have three different things, right? You have the request info, the user making their request, and who they want to impersonate. And from that, you get a final impersonated user, which you actually then impersonate throughout the rest of the stack. And that's how auditing and logging and everything sees that. Feel free to stop me if you have any questions. Okay. So when we try to get the impersonated user, the first level of caching is basically like, hey, this is who you wanted. This is who you were and what you were doing. If I have a record of that impersonation, I'll just do that. And this is a short 10-second cache. And so it skips all authorization checks and all those stuff based on basically all of those inputs, right? But it is sort of fully dependent on all the authorization attributes. Like, so basically the exact requests you were making. So if you're sitting there like getting pods or whatever over and over, like as a scheduled node, you'll only hit this once every 10 seconds.
Attributes have a lot of dimensions.
Yes.
Does this mean we are caching all of those dimensions? So if if I'm making lots of slightly different requests, is this we're caching on every variant of those attributes?
Yes, but the cache is compressed into a hash. So your cache key is still basically just the cache key is who you are and the hash of everything else. So it's namespace to you and then who you are. So we could certainly make it even fancier and give you a number of limited to you. We could do that if that would make you feel better. That would not necessarily be too hard to add. But it's like if you like say I want to impersonate like while getting like pod and the pod has like a 200 character name, that doesn't meaningfully change the size of the cache. It's still going to compress down to your username, which comes from the authenticator. So I assume you can like
So
make
the size of entries is not problematically
right.
variable.
But the number of
Number
entries
of
can
entries.
be large, but it is still only for 10 seconds. Like there's no configuration. It's 10 seconds.
Okay. I'm not sure about like that. Make a note there to like think about whether we should limit the number of cache entries associated with a given user.
The decision will be the same as long as we only look at the verb. What is it, like the verb, the resource API group?
Any of the things that could inform
Exactly.
the
Whatever is
authorization
sent out
decision
to
have to be part of the cache. And our like the power of the constrained impersonation is that a lot more of these things can inform the decision, which is good, but it means our cache has to has to be a lot more detailed. I'm not. We can keep going. We don't have to.
Right. While we are here, do you all agree with this, or do you want me to try to make it smarter? It's a slightly different thing when we do caching stuff for like webhook OTC calls. I don't know. I was less comfortable trying to figure out what the cache key is when I don't fully know what it is.
So the selectors are a good example of like they are never sent. You can't express in RBAC even with the new constrained impersonation that like you can impersonate, but only when you have this request and these selectors, right? So it's never going to affect the cache key.
So we don't make any assumptions about how you're authorized, right? The authorizer, like the layer here is arbitrary authorization, not RBAC, right? So a webhook can totally take your label and field selectors into account, right? Here, what I'm saying is if they're not exactly perfectly fully formed, I'm not going to try to guess what the cache key is supposed to be. I'm just not going to cache it. And the requests will get more expensive, but they'll still get authorized in, however we decide to authorize them. I'm just not going to try to cache them to make sure my cache understanding is exactly right.
I mean, knowing that one of the reasons one of the first uses of label and field selectors was to scope down kubelets. So the kubelets can only list watch their own pods and list watch themselves. So anyone using node impersonation to make pod and node requests is going to be doing the same thing.
But they're going to be well formed.
Oh! I missed this was the error path.
Yeah. The error, like if basically if I don't exactly know what you asked.
Yeah, sorry, I missed this was the error path.
Yeah.
I think that's fine.
Yeah, we could try to make the error path have caching. I was just like, at least the like if your node agent that's making a bajillion requests isn't well forming them, just make it well form them. Like obviously it's not you've either confused what you wanted to do, or you're using like a really old API server or something. Just, I don't know, just do the right thing. Don't expect me to guess what you meant.
Yeah, I think that's probably fine.
But otherwise we do include.
Sorry, I totally missed that was the error path.
Yeah, so like down here, right? Like when we are building the cache, like your field selectors are in there and your label selectors are in there.
Okay.
But yeah, all these interesting. David, you unmuted for a second. Did you have a thought?
I was just going to point out that it's the error path, so it doesn't really matter to me.
Yeah, but I wanted to make sure, right? It is a technical way of
No, I was just clarifying because I knew that if Jordan saw that, he'd be fine with it.
Okay.
I think the big money is, are we going to have a separate cache for this? I think it's okay and reasonable to have a separate cache for this.
So we have lots of separate caches. So let's make sure we agree on the separation of
them. How many do we have?
We have one per mode, one on top, and another one on top. So like let's make sure we agree. So I was like, all right, we are concerned about the cost of this. So I'm gonna fix the cost of this to be basically 0, but we best agree that we want to spend some memory up front. So we have this outer cache that's basically saying, okay, if like the whole thing makes sense in the last 10 seconds, cool. I'm gonna just let you go through. And at the end of all this, right, if everything succeeds, that's when I cache, right? So only if there's no error and I got a user, then and only then do I stick something in the cache, which, is the only sane thing to do. Then the other much simpler cache we have tries to remember for a given username which impersonation mode did they use successfully, so that it can change the order to include that one as the first one that it tries. It still tries all of them, just it tries the one that they succeeded with first. And this one is just a really simple LRU cache with just one entry per username, and it's just username to the mode that they were successful with.
And it's size scoped, I assume.
Yeah, 1,000 entries.
Yeah, I'm okay with that.
Yeah,
yeah.
We change our order. This is breaking my brain, Mo.
But so because we will always go through every possibility, then I don't think the order in which we try them matters.
Yeah.
And so I do understand the optimization there, especially in a world where this is new. And right now, at least in the initial implementation, the legacy mode was tried last. And I can see Mo looking at that going, I don't want that. The vast majority of my requests are going to have
100% of impersonation requests are going to fail the first.
So I get that. And because it doesn't matter what order we do it, I don't think it matters whether it expires based on time. I think size is fine.
Yeah. And if all fail, this factors into like what error message do we return? If all fail,
You'll always get the constrained one because that would have always been the one you tried.
Okay.
Because you wouldn't
so
have memory
even
of
if we reordered the checks we did, if we ended up doing them all, we'll still return the message associated with the most constrained one. Okay.
Yeah, because you wouldn't have had a success to change the error message.
Okay.
All right, Mo. So you got 2 caches.
Excellent. All right.
Go on the third one.
The third one. Okay. So the third one is within, so once we have passed the authorization check, that's the impersonate on bit, and you're going to start impersonating the actual user info, right? So the username, groups, or whatever. So this part of the cache is no longer dependent on the attributes of the request because those have already passed, right? So now you have a cache that's purely dependent on you, the user, and who you want to impersonate.
And this what this does is it is going to make it faster when I have a client that is making requests trying to impersonate the same user and is trying to hit like 12 different resources.
Right. And
I will say you are gonna need to like find a way to describe what these do. I'm trying to think what I predict that would be. That would be a time-based cache, right?
it's the same cache. It's the same 10-second cache reused, just with there's just no attributes, right? So it just ends up, but this cache exists within this mode only, right? So it's already scoped down to the verb and everything because it's literally a different structure altogether. But yeah, so when you make 2 requests, the part where you're like impersonating the actual user info doesn't have to be rerun. It's just the impersonate on bit, which is constrained to the request info, is the part that runs again.
That makes sense
Yep.
to me.
Okay. It's been a while since I've read the constraint impersonation cap. Say all our caches are empty. How many authorization checks do we do before we get out of the impersonation filter in a success
3.
path?
For which mode?
Like say the first mode we check is successful.
Okay,
I
so
think it's 3.
so yeah, so it's
3.
so you have the 3 or the 2. So we'll talk about schedule node, right? So first the filter has to match. So it'll be like, okay, yes, you are indeed trying to check that you are on a schedule node. So then we would
There's no auth Z checks there. That's just saying like,
does it make sense at all to try?
okay.
And so there's no auth C checks. Then we do the authorization check for impersonate on, which is specific to the attribute. So that's your first one.
Okay.
And because the constrained impersonation mode for schedule node only lets you set the user info, then we will get the second check inside here for the user for the node object. So you get 2 checks. You have 2 check
Plus the check to see whether that user can actually do the thing later on, right?
That's
It's later. You only
that's outside impersonation. Like that,
Okay. Then yeah.
I'm talking about how many authorization checks are there inside the impersonation filter
Gotcha.
in the happy path, successful path.
Right. So there's this one.
Yep.
And then the other one is basically the existing ones where we say, okay, username, UID, groups, right?
But we don't do those in the if associated node passed.
Yeah, because associated node passed,
Yep.
your wanted user only has the username set.
Yep.
Nothing else has it. So even though the code says you could have those checks based on the runtime state, obviously there will be no groups to check.
So if I ask to impersonate associated node while I'm doing a pod list request, we will do an authorization check for impersonate on associated node list pods in this namespace.
Yeah,
and if that passes,
then we would do impersonate. Sorry, which mode were you in? Were you on
associated node?
Okay. So then you would do impersonate on associated node with resource nodes and the node name cluster wide.
Okay, so that's 2 authorization checks.
Yeah. But there's nothing for groups, nothing for UID, nothing for extra.
Yeah. And that is independent of the attributes of the request.
Correct.
Okay.
And that's why that second cache exists, because that cache has no attributes that it takes as input. So if
Okay.
you made the second request, that first check has to run because the attributes are different. The second does not need to run, assuming it's within the 10-second window, of course. So it's basically the first cache is not super useful, other than when you're just making literally the same exact request over and over, which doesn't necessarily seem to be the most likely case, but maybe. And we have both.
Okay.
Yeah. But yeah, so basically, if we go back over here, I guess I'll start from the top, right? So, so when we try, we get the mode that we want to try, and like so one of them is or is not going to work, right? And so the modes we have are ordered like this, right? So we try schedule node, right, or associated node, arbitrary node, service account, just user info, and then legacy. Now, for example, one of the differences in behavior between legacy and user info is user info will not run if you appear to be a node or a service account. It will say that you need to fall into one of the 3 more specific buckets.
As I recall, that was pre-existing behavior. I liked that behavior.
I guess yes, pre-existing behavior in the PR. But
Yeah.
this is different than what legacy impersonation does, where
Agreed.
you
Okay.
kind of fall through until you like get permissions.
Yeah, the fewer ways we can fall through and have to like do a bunch of checks that are expensive and might fail, the better.
Yeah. So these 3 modes from constrained impersonation are basically like, okay, you must only set the username, and then you must first schedule associated node, you have your check. For a regular node, it's just are you a node, and for service account, is it are you a service
So the
account?
most modes we would have is 3, which is the case where you are impersonating a node name. So scheduled node or associated node matches, arbitrary node matches, and legacy matches.
Correct.
And the most authorization checks we would have for the node ones are
2 each.
2, but only, yeah, so 2, 2, and then 1 for the last one because you only specified a username.
Yeah, so it'd be 5. It's like the absolute worst case. And then they'd get cached, and the next time you come around, it'll either
Does oh, and the fact that that user, well, if all fail, what happens if all fail and you do it repeatedly? Do we cache negative results?
there's no negative caching.
Okay. So if all fail, we won't remember that we fell back to legacy and that was what worked and we should start with that the next time. So we will try all 5 and fail all 5.
Well, I mean,
We would probably not try both because probably the first check of each of the node modes would fail if you hadn't granted it.
yeah, you're right. Yeah, so it's 1, 1.
Probably 3
Every
checks.
3. Yeah.
Maybe I misunderstood then. I thought that top level cache was going to tell me that, hey, you succeeded with the legacy impersonation.
I'm talking about the failure mode.
Like, Jordan's just asking if nothing works.
What's the like? I'm trying to impersonate and I didn't grant any permissions and it's just going to fail. Like, how expensive is the failure?
Okay.
Yeah, so the worst case is 3. Whereas
Yeah, the worst case in like you don't have any permissions, you just haven't set anything up and it's failing. I think it's 3.
yeah, I mean that shouldn't realistically happen because you're not going to get anything done.
That will always happen.
Well, yeah, it will happen in a hot loop. I guarantee it. It's happening right now.
Sure, that's fair. That's fair.
Okay. All right.
So there's no negative caching, so that could happen over and over. But once you have successfully impersonated, even if the 10-second caches have expired, the LRU probably has not because it's got 1,000 entries in it, so it's probably going to last for a little while. And because it's based on username, so you have to have more than 1,000 unique users using the system before it wraps around.
I'm running a daemon set on nodes. I'm definitely going to have more than 1,000 users using this.
The service account should be the same, right? That's
Oh, it's username. I see. Okay, so a daemon set would only count as one. Oh, cool. That helps.
Yeah, and so like if it was using the service account mode or whatever, right? We would remember that, and so then we would do 2 checks for it: the service account impersonate on check and the regular impersonation need check with the mode tacked on there. And yeah, so it'll be 2 instead of the legacy impersonation, which is 1.
Okay.
So it's not that bad. And we would have extra caching, so that really it's like 2 checks per 10 seconds kind of deal is what we're hoping for. Sort of ish. Depends on how they make requests and what the shape of those requests are, etc. I don't think it's sort of like unbounded in cost.
Can I ask why we don't cache the negative case? Like, I mean,
So what happens with the negative cases we found long ago on namespaces is you have a quick user goes through, makes a request, fails, grants himself permission, and tries again. And if he fails, he's very confused. And so people get upset when granting permissions doesn't act quickly.
Yeah.
okay.
Yeah. Negative caching is just very annoying from the user's perspective, and also can turn like a blip into like, instead of it being blipping for a second, now it's like, oh, whatever your negative cache was. So like if it's like 3 minutes, cool. Your blip is not going to last for 3 minutes. Awesome.
Good question, though, because that did come up many years back when we were doing some of the initial caching for namespaces.
We do have negative caching for external systems. So like when you set up a webhook authentication,
You get to decide that.
You
right?
you can say, I want you to remember a negative result. And that's more reasonable because it's a lot more expensive to go to an external authorizer. And it's a lot less likely that you're like going to apply a manifest and then 10 milliseconds later, like the RBAC authorizer is going to notice the RBAC bindings you just created and authorize you. Like when you're talking to an external system, it's less likely that that thing is basing its authorization decisions on something in the Kube API server. It's not impossible, but like probably it's some IAM system out somewhere, and like you're writing to that independently. It might have its own propagation delays and things. So we do allow configuring negative caching for webhook authorizers if you set up your server that way.
Yeah. And if in those cases, then the authorizer decides basically how long it's going to just or how long it's going to remember that it failed you. So your calls to the authorization layer might not be really expensive. Just
Right.
internal cache. Lukash, did you have a question?
Yeah. So one thing just came to mind with the ordering of the like trying the most recent one first. I don't think we want, but just to make clear, we don't want. Like at the moment, what happens if we just check the allow? If we send a SAR and we get something back, we check just is it allowed or not. Do we expect or see any use case where someone's saying, I don't never want this person to it's not a no opinion, so like don't go the chain, like never always forbid this person from doing this. It's a kind of words, but just asking.
These are actually 3 different modes. So there are, when you ask to impersonate a given username, there's 3 different ways you could be authorized to do that. And if one of those ways is denied, then okay, like user info was denied or legacy was denied. But scheduled node, associated node was allowed. Like the path of legacy impersonation was denied. You're not actually doing legacy impersonation. So it's okay to check and honor and allow for associated node. It's not really a chain. It's just alternative ways you could be authorized to do what you're trying.
The resulting user isn't different.
Yeah. So it's not like an ordered list of authorizers making decisions about the same.
So the node is similar, but it's not. I agree, it's not the same. I just wanted to kind of like put it out there that we don't get into a like point in the
all the semantics about the order we check your configured authorizers in, and whether they can allow or deny or no opinion and short circuit each other. Like all of that logic still applies. It's just within the context of checking one of the particular modes.
Yes. Just like we need to. I mean, I'm sure this group will remember, but just like if other external people would like to kind of extend this idea, then like need to remember that all of the modes have to be completely disjoint, basically. That like otherwise it never, or you can get into problems if they wouldn't be.
Yeah, if you have a authorizer you want to be able to deny impersonation requests, you can still do that. You just have to route all the authorization checks to that authorizer, and it can deny them all if it wants.
Yeah. I this shouldn't matter, but I think so. The existing legacy impersonation is not actually structured like this. I think it fails on an error from the authorizer, which I don't think it should do. And so I did restructure it such that like your RBAC errors do not, or the deny, or not a deny, but did we lose David? I think we lost David.
Yeah, I need to drop.
But to me, this is more correct. This is how authorization is actually supposed to work, which is that if you get an allow, it doesn't matter if there was an error because there was an allow, and the error is just informative.
Do you want to log it or not? If it's okay, even though it's working.
Say that again.
Do we want to log the error even though it's allowed?
Oh, do we want? I think if we
remember
want to.
How RBAC does it anymore.
Yeah. So the where is with authorization, right? So what do we do here? Yeah, so we don't log it here, so I would say we shouldn't log it there. We just say if it's allow, set the audit annotation, which is whatever.
Okay, yeah, that's the audit annotation. Yeah, that's fine.
Yeah, so I think I'd say that because we don't feel the need to log an error here. That's what I was trying to become consistent with is like authorization is if it's allowed, then it's allowed. It doesn't really matter how you got there. It's just there's a reason associated with that allowing, or there may be. But if there's an error, that error is just informative. It does not tell you to fail the request in any way. But the legacy impersonation today is just literally like if error does not equal to nil, the request, and I'm like that's not actually what I want.
Yeah, that seems fun.
Okay, so I think one of the takeaways I got based on questions asked is add more comments to what the caches mean. It's fine to do. Add more detailed comments here, which is fine. I can do that. I don't
Building the keys, constructing the keys for the cache. It seems like if we have two caches, one of which includes all of, there may be opportunities to avoid duplicating work between the two caches. If one of them includes attributes and one of them doesn't, like consider how much work you're doing to build the cache keys when they're complicated.
Yeah, I thought I can do it. I was just like, oh, it's so ugly because you have to like really carefully remember where you're building the cache key. Right now, it's like, okay, I know I'm doing it correctly because I'm doing it at the point that I need it, and I know what my inputs are at that exact point. Like how I definitely did not want. I was really nervous about trying to pass the cache key around and then like making sure that I like it matches.
Are the 3 dimensions like who is doing the impersonation,
What request are they
who
making?
they're wanting to impersonate,
Yeah.
and like other like the attributes of their request, like their verb and resource and API group, and like those 3 dimensions. And the top level cache like caches on everything, and then we carve out like who you are and who you were impersonating, and like anyway, if those like calculating the keys of the cache for those 3 kind of higher level things might be an opportunity to then say we have a cache on all 3, we have a cache on just 2, we have that might be a cleaner way to structure it.
Okay, so I could upfront generate all the cache keys for a given request, which would be 2 of them. Maybe give them a different type of string instead of just a string, and then pass those down as inputs.
Or like I think clarity around the types would help. It would also help when you're looking at a particular cache, like what even are we caching on here? So clarity there might help. Lazy construction. So like if we get to a point where we succeeded and we need to cache a thing, I'm gonna need this cache key. So at that point, I have something that can make it for me if I haven't already made it. And if I've already made it, then reuse the one I already made.
Yeah, I could do that. Yeah, so it could basically be a lazy initialize struct that's per request, and there's no Go routines inside this handler, so there's no concurrency to worry about.
That's probably how I would do it. So it's lazy, it's as needed, and then construction is done a single time, and it's clear for each cache, like which of those pieces am I using in my cache info as my key.
Okay, that's fine. Okay,
I also need to drop.
Thank you, Jordan. And David.
Yep.
Okay, Jordan, feel free to drop. Does anyone else have any questions before we end the meeting? Okay. Thanks y'all for coming. Have a good rest of your day.
Cool. Thanks. See you around.
Yeah.